one of the things that I think about mathematically about me is that I'm from a family. I have one sister and two brothers, so there are 4 kids. And we seem to have everything as kind of a 3-1 split. 3-1 split. So we have, 3 of us are kind of math people and 1 person is not. 3 went on for advanced degrees, 1 did not. 3 have children, 1 does not. So it's like this constantly 3 of one and 1 of the other, and it's not always the same people. So I always think of that as kind of a mathematical fact of my family. But it may be something that has to do with numbers of birthdays, or it may be something generational. I've had people who have talked about the birthdays and how that fits into other family members or variety. So if there's something you think about that's mathematical about you, you can put that down. But it could be something unique. I had one person this summer who was planning to go to do mountain climbing in Nepal. And fortunately, of course, they had to cancel the trip. But that's kind of unique. So is there something unique, some place you've been, something you've done, something about you that is really special? You could put that down also. And once you just put a little note down on these, then share those with your table group. Even though you may know some of the people, maybe there's some things you don't know about the other people at your table group. So I'm going to give you just about 5 minutes. Thank you. And I will collect the papers just so that I can get a chance. And over the week, I'm going to try to get to know you and learn your names, but I know that's going to be really hard. And your name tags are under the table, so it's really hard for me. So if there's any way you could, tie your name tags up higher, because I really can't see them at all, so they're not helpful. Yes, table 10 seconds. We might do that tomorrow. We'll see if I can find something for this afternoon, in fact. Share with your table groups what you have put down. I think we're missing a couple. Thank you. Oh, wow. Oh, wow. No spreading out the celebrations, huh? Thanksgiving, Christmas, New Year's, and birthdays. Really? Whoa.
Kind of felt out of place when I was born on the 17th, but my parents' anniversary is on 8/17.
Hey, okay.
Oh yeah.
Oh, I can't believe that. I can't believe that. That's pretty unique. Okay. I'll remember that. When I read that, I'll go, I know who that is now. How'd you do at your table? Do you need a little more time, or are you about another 2 minutes? You're gonna have to talk fast. 2 more minutes. Okay, your 2 minutes are up. Would you please hand your papers to someone at the end, and Tracy will come and pick those up. A lot of what we're going to be doing this week, at least in my sessions, is looking at problem types and strategies. So word problems are not all created equal. That, as you know, if you're using word problems with kids, that some are going to be easier and some are going to be harder. And you can kind of sense that based on the look on their face often when you give them a problem. So we're going to focus a lot on trying to identify what makes problems easier and harder. So the first activity that you're going to do is you are going to actually rank problems in order from easiest to hardest based on your knowledge so far. So there are 9 different problems in this stack, and you're going to get in groups of 3. Now, not all of your tables are groups of 3, so you have to find someone is a group of 3. So some of you may have to move just a little bit. Your task in your group of 3, first of all, once you find your group of 3, send someone from your group up to pick up a set of cards. Then you're going to order them from easiest to hardest, base your rankings on how easily you think a student could solve the problem. And we're going to eliminate the reading factor, because you could read the problem to this student as many times as needed, so it's not about their ability to read themselves. It's ability to pay attention and listen and to read it along with you to see if they understand it. And then you're going to record your rankings. So they're labeled A through I. And so someone in your group of 3 is going to record easiest to hardest A through I, or whatever it's going to be. I'm not going to give you a lot of time. This is not about, oh, I have to get this right. No. This is about processing the problems so that we can talk about them more. So don't spend a lot of time saying, oh, I don't know whether this problem is harder than this problem or easier. Kind of get them just in the general, but make a quick decision. Well, okay, let's put this one here. Okay? I know they're pretty close to the same. I'm going to put this one first and this one second. They must be ranked. They cannot have any that are exactly the same. Any questions about that? Okay, I'm going to check in with you in about 5 minutes. I think it may take you longer, but don't spend a lot of time on this. It's more that I want you to process these problems so we can talk about them. Okay, so find your groups of 3. Some of you are going to have to work harder finding a group of 3 than others. Oh, that's nice of you. Okay, you're okay with this? And someone has recorded it? Okay, are you okay with this?
I think so.
And someone's recording it. Okay. Okay, once you have it in order, someone needs to record it. You are quick. I like this. Wow. Okay, so I'm going to have you start putting your list up over here. So easiest to hardest on the bottom. Just put the letters. Okay, you're going to start putting your list, and you're going to start putting your list up on this chart and vertically, easiest to hardest. Okay, in order. Okay, so you're going to put your list up on this chart over here, easiest to hardest vertically. Okay, you're going to put your list up again over on this chart. Yes, you're going to put it up on this chart over here, easiest to hardest. You're going to put it up on this chart over here, easiest to hardest vertically. Okay. No. Okay, so someone's going to record this up on the chart, easiest to hardest. There are two charts up there. There's one over there, one over there. So someone has it written down. No extra writing today, is that it? Blue's good? Okay. Okay, you're going to record your rankings up on one of those two charts up there. I have the pen for you. Here.
Thank you.
We're going to look at them, so it's up to you how you want to do it. But someone needs to go up and record it. There are two different charts up there. Thank you. Thank you. Thank you. Once you have recorded them, I will take the pens back. Thank you. I'm going to grab your pen. Thank you. Thank you. Okay, I think we're missing one group. Oh, okay. Okay, so see if anyone has exactly what you had. Oh, are these the two? These two are the same, right?
No, like the brown and the blue are the same. But the red, that's
Aren't the brown and the green? D, B, G, H, F, C, A, E. This one and this one?
You're right.
No, not the same. These two are the same. Okay. So I found these two are the same and those two are the same. I don't think they're the same as each other, no. Are there any others that are the same? Okay, which ones? The purple and the red. These two, yes, I got those. Has the same as this? E, A, C, F, H, G, D, B, I. Okay, never mind, okay. Close. Any others? Okay, so to make it a little bit easier, I'm going to split them into groups of 3 because typically we start to see some patterns. So do you see some patterns if I put them into groups of 3? Okay, so what do you see in the top group? EAC or AEC or something, right? Except for we have one outlier. Okay, we have one outlier. How do you know that they're all right? Okay, how about the middle 3? HFG, basically, except for this one. And what about the bottom ones? Oh, there's a B over here too? Okay. Oh, yes. And the B and the G are switched. Okay. Otherwise, do we have pretty much the same in terms of groups of 3? Okay. So how did you decide how to organize them? What were your thoughts as you were putting them in order? Multi-step, how many of you thought multi-step would be the harder ones, which looks like it from almost all of them? Okay, then what else? Okay, so how many of you thought addition, subtraction, multiplication, division, multi-step? Okay, so your experience with kids, absolutely. Okay. Okay, the length of the word, okay. Okay, remember it was going to be read to them, but still that can influence it, whether kids are willing to do it. Okay. So why did you go addition, subtraction, multiplication, division? I mean, there's no addition problems in here, technically. But why did you do it in that order? So that's the way we teach it. Is that the way they learn it? But in terms of, part of what we're going to be talking about this week is what are natural strategies for children without instruction. So if you are giving problems to kids without teaching them the specific ways to solve that problem, are the addition ones the easiest, subtraction ones are next easiest, multiplication ones are the next easiest, and then division? Or is that necessarily true? Okay, so you're thinking maybe addition and multiplication are easier? Okay. Okay. So why do we typically teach it addition, subtraction, multiplication, division if it, yeah, it tends to be tradition. The books are in that order. But so what we have to do is we have to make this little mind shift that we're trying to focus on how children actually learn best and what they understand, because part of what we want to do is we want to help them to be successful while still challenging them, right? And so if we know what makes problems easier and harder for them, then we can start with where the students are so that they can feel some success, and then we can push them to the next level. And so they're not always, I mean, if you give a problem to the whole class and everyone looks at you like, how much are you going to get out of that particular problem? You have a lot of students who go, I don't know how to do this. We don't want that, okay? But that doesn't mean we're not going to give them challenging math. What it means is we want to start at a place that they can begin easily and then keep moving them forward until success is not about how easy it is to solve, but it's about the satisfaction of figuring it out. So that success becomes about challenge, not just about being quick and easy, okay? So any other features? I think we did orders of kind of the operations in the order we typically teach them. You talked about multi-step problems, and you talked about the length of the problem. Anything else that gave you?
We also consider, like, some readers, because we know to a certain degree what content if it was worded different, like it wasn't as straightforward as some readers, and those would be harder, even if the actual math part of it's not harder.
Okay, everyone agree with that?
Understanding what they needed to do would be harder.
So this understand. Can you give me an example of one of those, maybe?
One about the tadpoles in the jar, just the way it was worded, would be things like they don't whereas if it was worded a little differently, they'd know about it.
Right. That's actually an interesting. Yeah, it's actually an interesting one because a lot of kids don't know what guppies are either. So, okay, so that can, and so context also can make a difference. So the way it's worded in the context. Anything else?
Once we group them into bigger groups, we put double digits and put those in the harder rather than the single digit.
Okay, so the size of the number, even though they're relatively close in size, but there's some variation. Okay, anything else? Ah, okay. So what would make it something that's simpler to arise at? Right. Oh, that would make it easier for something else. Okay. Anything else? Okay. How successful do you think your students would be? So think about your second and third grade students. How successful would they be solving these problems? Like all of them?
I have kids that do independent practice and they can computate problems and then they turn it over to the word problem side and it's without even looking at it. I need help. They won't even read it. So it's getting past that, breaking down that wall of fear with word problems.
And again, part of that is because of their instruction.
I can remember doing it as a kid.
Yeah.
Anxiety.
Yeah. Okay, so second, third grade, are these appropriate for second and third grade? And would they be mostly successful, do you think? Mostly successful? No, they'd be doing them individually. But we could do it as we actually did this with interviews, so in one-on-one interviews, but they wouldn't.
What part of the year?
Beginning. They could have whatever they wanted to solve the problem. So beginning of the year, what do you think? Okay. So you're thinking maybe this would be a little bit challenging for your second and third graders, especially at the beginning of the year? Okay. 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 So these problems were given to kindergarten students. There were 70 kindergarten students who were interviewed. So this was individual interview. However, they were allowed to solve the problem any way they wanted to. So they had cubes, they had paper and pencil if they wanted to use it. They could use their fingers. The problem was read in its entirety to the student each time they asked. But this problem could be read as many times as they wanted. So if the student, some students read twice. I mean, every student had it read at least twice. But some of them maybe had it read 6 or 7 times to them. But the difference was, it's a research study, right? Okay, so it's research, not instruction. But if the student said, so how many kids were in that problem? They couldn't just give the number, the researchers couldn't just give the number of the kids. They had to read the whole problem again. So that every student had to pick out the important information from the problem, but they didn't have to remember it from, after just 2 times reading it. Does that make sense? So we couldn't give them answers, but we could have them read it as many times as they wanted, no matter how they asked it. These students, I'll tell you a little bit about how this came about. So cognitively guided instruction is what was mentioned at the beginning of the session today in the whole group, because we are focusing on student thinking. And I'll give you a little definition of cognitively guided instruction. You're not getting the whole cognitively guided instruction package, because it is a professional development approach. Typically, we have a minimum of 30 hours in the first sessions, and then multiple years where we have more time. We have less than 20 of CGI in this particular group. So we're going to focus on student thinking. I'm going to give you a little bit more overview than what I typically would give. But we were in a research study. I went to the University of Wisconsin-Madison for my doctoral work, and we were doing a research study with a longitudinal study on cognitively guided instruction. How did teachers use information about children's thinking in their teaching? We didn't tell the teachers how to teach. All we told them was how students learn. And there's a lot of research out there about how students learn. So we did it. It was a K-3 study, K-3 group. But the only reason kindergarten teachers were involved in this research study was because we were in whole schools and we were doing primary grade professional development. And how can you say, oh, no, only first, second, and third grade teachers are going to get this professional development. Kindergarten teachers, you don't get to do it because we don't think it's appropriate for you, right? That would be kind of unfair. So we decided that we would go ahead and include the kindergarten teachers, but we weren't collecting any data on the kindergarten students. So we were collecting data on the first, second, and third grade teachers and students for 4 years. Okay, baseline data and 3 years after they had started professional development. What happened was we were meeting with the teachers every month, and the kindergarten teachers kept coming back saying, oh my gosh, you should see what my kids can do. And we go, oh, okay. So we decided we had to do a little mini research study on the kindergarten students. So this was near the end of kindergarten. It wasn't at the beginning of kindergarten. It was near the end of kindergarten. But we had 3 different classrooms, or three teachers. And we were able to do almost the entire class for each of those 3 teachers. And some of them had like morning, afternoon. Okay, so they may have had more than one class. And we just interviewed them. So this is the result. So the teachers in kindergarten had been doing a lot of problem solving all year long with their kindergarten students. These are questions I want you to think about. I'll give you the data on a handout, but I'm going to just show the data. So as you look at the data, were the kindergartners successful in solving these problems? Okay. Which problems are easier or harder based on the data? And do the data match rankings? Why or why not? Because these are the exact same problems we gave the kindergarten students. And how does this data influence what you think should be taught in mathematics? So those are questions I want you to think about. I'll revisit them after we look at the data. So here's the data. So we've broken it up into kind of the rankings, the groupings that you typically talk about. So these are all typically are considered subtraction problems, right? We're going to look, we look at both the correct answer and valid strategy. However, we're going to pay most attention to valid strategy. And how many of you have taught kindergarten? I'm sure some of you have. Okay. So what happens if a child is, for example, counting and solving the first problem and counting out the 13 and then taking away 6? Sometimes as they're counting, they go 1, 2, 3, 4, 5, 6. And so how many cubes do they actually get out there? 12 maybe instead of the 13 because they double counted one, right? Miscounting is pretty common in kindergarten. So this correct answer is only if they got the exact correct answer. The valid strategy is if they were maybe one answer off. In fact, it had to be one answer off. And if they had counted correctly, they would have had a correct answer. So their strategy was valid, but they just didn't carry it out because we couldn't ask them to count again. Okay, that was part of the research project. So we're going to look at the valid strategy because I think this is actually a better indicator of what the kids can do rather than correct answer. Okay, so what do you think? Does this match what you had predicted? That E is easier than C is easier than A? Ah, some of you. And are they approximately the same? Or are they some variation? This is the percent of students who actually solved it using a valid strategy. So they're, you know, E, A is about the same level of A, or do you think A seems harder because of the percent? Yeah. Yeah, it is. And if you look at the top, 46% of the students use valid strategies on all of the problems, so almost half of the students. And 63% used valid strategies on 7 or more of the problems. Okay? So let's look at the next set. So here are our multiplication and division. What do you notice about the valid strategy percentages? So F is pretty easy, isn't it? What about H and J and G? Not quite, but remember those percentages? Everyone got it? I'm going to move back. How does that fit here? So if we looked at percentages, and what we find is we've done this over and over and over, and that this is pretty typical. So which one is the easiest problem? And which one is the next easiest problem? The multiplication. Who was saying addition and multiplication was easier? And then which one is the next easiest? C, and then G, H, and A are really close, right? So we have a subtraction problem and 2 division problems that are almost the same level of difficulty. Does that surprise you? A little bit? Okay. And then here are the multi-step problems. And what do you notice about these? You were pretty correct, right? But still, almost 2/3 of the students were able to solve each of those problems. And what do you notice about the last problem, problem I? That's the one we did. Ah, there's a method to my madness. That's the one we did. And 59%, so over half of the kindergarten students were able to solve that successfully. Whoa. So you were telling me your 2nd and 3rd grade students couldn't do it as well. So why do they circle numbers? Because that's what we tell them to do. Okay, so what's wrong with telling them to circle numbers? It almost encourages them not to pay attention to the context. Yes, Ellen. So do they even have to understand the problem after the first day? You've kind of told them what they're supposed to be doing, so why do they even read it, which of course is why they don't, right? Because they know that we're working on addition this week, and so every problem that I'm going to do is going to be addition, so why do I have to read it? Right? Yes, they beat the system. They beat the system. We teach them shortcuts that then they use, which actually interferes with their ability to solve problems. In fact, as part of this longitudinal study, I had the opportunity to interview many students with these problems, first, second, and third grade, and the third grade did the worst on the last problem because they had been taught circle the numbers, look for keywords, pull them out, and they started to just, well, let's see, 2 and 3. So I'm going to add the 2 and the 3, and that's 5. 5 plus 7 is 12, and then take the 12 away from the 19. Or else they'll just add them all together. Or they paid no attention to the context. Kindergarten students and the first grade students did better because they had not been taught not to pay attention to the context. They actually paid attention to the context because this is how kids interact with their world. They have these kinds of problems in their everyday life, right? They're not written as word problems. They're actual events and situations that they deal with all the time. Yes, all of them were interviews. All of them had it written in front of them. Even the kindergarten students did. But we read the problem to all of them. I think the big barrier is that how they're taught in mathematics. That their instruction tells them not to pay attention to the particular context. Then they wrote the numbers down in the same thing. Yes. Yes. Because that's what they've been taught to do. Pull out the numbers. Pull out the numbers.
So then would it be more advantageous to not teach, say, addition for 2 weeks and give the test?
Absolutely. We need to think about mathematics much more holistically than what we do. Because what we do is we condition our students to be successful for 2 weeks and then forget about that and now let's do something else. Well, we'll be talking about that. Don't worry. Don't worry. We'll be talking about that. Okay? So, yeah, it's actually kind of scary because there is some data out in California. I think they did it at the Noyce Center. I think David Foster did, where kids get worse in mathematics the longer that they are in school. And so we are part of the problem. Because kids come into school with this rich knowledge of how to interact with their world, with numbers and even spatially, and then we kind of say, no. Don't use those natural strategies that you usually use. You're going to do it this way because this is what you're supposed to do. Because that's, as an adult, that's what we do. We totally ignore the natural things that they come in with. Okay, not totally, but. And then the textbooks aren't helpful in that. Okay, so again, were the kindergartners successful solving these problems? Yes. And which problems are easier or harder? Yeah, it's not the ones we typically think of. Okay, and I'm going to give you data. So can I have some, Tracy on? And do the data match your rankings? Not entirely. Some of you were pretty good in terms of at least getting the easiest subtraction problem. How does it influence what you think you should be teaching in mathematics? So talk in your table groups about that. What do you want to think about? You've already asked some really good questions. You need one more? Thank you. You need one more?
Can you remind me what are we discussing?
How do you think it should influence how you teach mathematics? The last question. The last question. The last question. Okay, I'm going to very quickly have each group share just one thing you talked about. We're going to start over here. It's a sentence or less. This is quick because we don't have a lot of time yet. So what's one thing you talked about that might influence how you think math should be taught?
We just discussed how it would be hard to collectively get the whole district or every teacher per child, kindergarten year on 12, on the same page, so it becomes a problem, and that's where.
Okay, so we need to deal with this, some of this institutional thing. Isn't that part of what they're talking about, that this grant is supposed to change? Okay, what about this group? One thing.
How useful is it to just put it out there and say, show me how you use that?
Okay, how about this group?
I just had an idea of, there are some things that we can't change in terms of, the progression of things to do, but, we do more math than just in math class. There's lots of ways that you can incorporate math into your day that's not limited to just, the time you
Okay.
have on your book that says math.
Okay, good. What about this group? One thing.
I just thought it was interesting. Was this just in one sit down that they did this? That one session
Mhm.
that they gave you?
Yeah.
And they were able to shift between all of these different
Yep.
techniques and students to have realized
Right.
that all the time.
Yep. Yep. This group.
You talked about how you need to, like something so linear in our subject matter, whereas like reading and math with math, if there is reading in math, like if they are just in passive, then they should be able to read a word problem and understand what's going on.
Mm-hmm.
Like if those kind of emotions.
Mm-hmm. Absolutely. How about this group? One thing.
I think just that shift from being so programmed and logistical, chapter 1 and chapter 2, trying to make that shift into this type of thinking.
Mm-hmm. Okay.
That's really cool.
Okay. So let me tell you about what makes problems easier and harder, and then we will be spending a lot of time on this tomorrow. So the length of the problem and the specific wording of the problems, like keywords, is less a factor than we think. Now, that doesn't mean it doesn't influence kids, because it does. Sometimes the context and the length can, but it's less of a factor than we think it is. Keywords actually interferes with students' ability to solve problems. That it shortcuts their willingness and need to read the problem. And we're telling them that that's a good way to do it, then they're not going to read the problem. And so we actually bypass comprehension. The other thing is that many of the keywords are in many of the problem types. So it becomes, maybe it seems easier at the lower grades, but as you get into more complicated problems, altogether can be multiplication, or it can be addition, or it can be multiple step, or it can be, right? So we have to be very careful and get rid of keywords. Sorry. Most important factor is whether students can visualize what the problem is asking. So can they actually visualize and act it out? If they can act it out, then they can probably solve it. So that's why some of these multiple step problems were really not that hard for the kindergarten students. They didn't have to know if it was addition, subtraction, multiplication, or division. It didn't really matter to them because they weren't thinking about operations. They were just solving the problem. And that's one of the things that is often wrong in textbooks, is that they often will say, here's the problem, write a number sentence, or what operation are you going to use, and then solve it, right? Kids don't always know the operation. They don't always know the number sentences. But guess what? They often can solve those problems. And you want to have them solve the problems first, and then you can build in operations and number sentences after. Because it often stops them. That's one of the reasons many kids don't like word problems is, oh, I have to write a I have to write a number sentence, or I have to, figure out what operation it is, and I don't know what it is. So if we get rid of that, just solve it. Just solve that problem. If I had asked you, again, to write an equation to go along with the bus problem first before you solved it, even if it wasn't algebraic, would you have been able to do that? It would have been pretty hard. Okay. And we're going to talk more about features that make problems easier to visualize tomorrow. So I'm going to show you some videos of kindergarten students. And these were kindergarten students who were in the same cohort of kindergartners during this research study. So they're old videos. However, they are not the actual students in the research project. Okay, they were from a different school. So I want you to see, what do they know? How do they solve the problems the way you would? Why or why not? So that's really what I want you to be looking at as you watch these problems. And the problems are similar to the ones you just sorted, but they may have a slightly different context or names in them. Okay. This is Caitlin. She is solving the problem with, I think it's C. Carla has $7. How many more does she need so that she can buy a puppy for $11?
How many more dollars does she have to earn so that she will have $11 to buy a puppy? Caitlin has $7. How many more dollars does she have to earn so that she will have $11 to buy a puppy? Four?
Okay, so in your table groups, what did she do to solve that problem? In your table groups. Didn't I say that? Yeah, didn't I say that? In your table groups. Okay, so what did she do to solve this problem? Joe? She counted out the 7, and then she started 7, 8, 9, 10, 11. How did she know when to stop? And how did she know what the answer was? Okay, what she had counted. Does this fit the structure of the problem? What's the problem say? She started with $7, and we want to know how many more she needs to get to 11. Okay, we typically tell kids this is a subtraction problem, and how are we supposed to solve it? 11 minus 7. Does that make sense? Does that make sense at all? If you told Caitlin, no, 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 you need to do 11 minus 7. She's going, but I'm getting more money. I need to get more. So why would I want to subtract? Right? So what we need to do is we need to recognize what the students understand and what makes sense to them. You had a question, Penny.
I do, Jeannie.
Mm-hmm.
I totally understand the whole, yeah, she counted up, and the numbers are really small.
Right.
They obviously could not count up if they were talking about, you know, they had $5,767 and they need $12,372 to buy a car.
Sure I could.
How much more do they need?
I'm not going to count up by once, but I still could count up. And part of it is that we're not thinking about what they're going to do with larger numbers right now, because what we're trying to do is what makes sense to them, because what we want to build in is the recognition that addition and subtraction are inverse operations, okay? So that once they recognize the relationship between addition and subtraction, then some of them are going to subtract and some of them are going to add, some of them are going to count up, some of them are do something that calls incrementing. Even with large numbers, they can increment up, okay? And do it fairly quickly and easily. So what we want to do is to not tell them right from the beginning that they have to subtract for this problem, because basically what you're telling them is, you don't understand mathematics and I do. And so do what I say you to do and don't think about what makes sense to you. Isn't that what we're telling them? So what we want to do is we want to start from where they are, because eventually I want them to be able to recognize I can add for this problem, I can subtract for this problem, and I'm not adding the two numbers, but I can add up until. So we want to be thinking about the fact that this problem is this. 7, how many more do I need to get to make 11? And kids will often do this, and then when you ask them to write an equation, let me tell you what equation they write. You want to guess? 7 plus 11 equals 4. And what are we going to tell them? We say, that's not correct. Do you really believe that 7 plus 11 equals 4? That's because you don't understand what kids are thinking. Otherwise, if you really understood, then you would say, oh, I know exactly what you did to solve that problem. You started with 7, and then you added on until you got to 11. Is that what you did? Or I'm going to ask them, can you tell me how you did? And, oh, this is not how we write it. This would be how we write it. And so now what I'm dealing with is I'm helping them to make math connections and deal with the conventions of mathematics, but I haven't told them that they solved the problem wrong. Right? I get exactly how you did that. That's a really good way to solve the problem. This is how we would write it. Isn't that different? That's very different. So we have to recognize as teachers what's natural for kids. And what's natural for kids is that they really follow the structure of the problem. And if that's hard for us, then that's something you're going to have to really work on this week. To follow what is happening in the problem. Because if I can act out what's happening in the problem, then they're going to be able to, I'm going to be able to hear what they do, and I'm going to be able to build on that. And eventually, I want a student to say, well, this is what's happening in the problem, but I could subtract to find the answer. But I want them to believe math makes sense. That's the first part of anything we do. Math makes sense. Okay, so let's hear, this is Casey solving the same problem. He's also a kindergartner. And how is this the same and different than...
Casey has $7. How many more dollars does he have to earn so that he will have $11 to buy a puppy? 4. And how did you get that?
8, 9, 10, oops, 8, 9, 10, 11.
Okay, so, how is that the same and how is it different than what Caitlin did? Talk in your table groups. watching my time, and I'm running out of time. I'm running out of time. But so what did he do that she didn't do, or what did she do that he didn't do? She counted out the 7. Did he need to? No. He abstracted part of it, put it in his head. A slightly more sophisticated strategy. Does it still follow the structure of the problem? Absolutely. Here's the next problem she's going to do is the problem with, which one is it? A, which James has 12 balloons and Amy has 7 balloons. She's going to do that problem next. Talk to a partner, predict what is she going to do to solve that problem. It's A. James had 12 balloons and Amy has 7 balloons. What's she going to do? Okay, everyone have an idea?
A friend of hers has 7 balloons. How many more balloons does Caitlin have than her friend? Caitlin has 12 balloons. Her friend has 7 balloons. How many more balloons does Caitlin have than her friend? Oh, this is a graph. Okay.
So what's she doing? A graph. So what does that mean? Comparing. How many of you said you thought that's what she would do? Okay. Does it match the structure of the problem? Yes. Yes, right? Because someone has 12, someone has 7. Isn't that what's happening in the problem? But the kids don't. So you may, but kids don't. And now our job is to switch to figure out what kids would do. And isn't that what the problem is asking? Yeah. Okay.
You want to check your cubes? You can see. Caitlin has 12 balloons. You have 12 balloons there? And your friend has 7. How many? Then you have 5 more than your friend? Okay.
Okay. So this is one of those examples of a valid strategy but an incorrect answer. Did she understand the problem? Yes. Absolutely, but she got a wrong answer because she had miscounted her 7. She counted out 8 instead of 7. Okay. So how many of you said you'd start with the 12 and take away the 7? How many said they'd start with the 7 and add up until 12? Because you'd seen her do that before. And some of you said she'd compare. Which one matches what's happening in the problem? What she did. So even though as adults we would think of it in another way, or we'd think of this as subtraction, kids don't. Kids don't. So we're going to have to really pay attention to what the structure of the problem is. And initially, that's what kids do. And we do want them to get away from that, but initially, that's where they're going to start. And that's a good thing. That's a good thing. I have one more kid, and then I'll give you a break. This next problem is Rex. Rex, again, is a kindergartner. All these are kindergartners. And Rex is solving the division problem with 20 cupcakes and putting them into 4 boxes. Okay? So Rex is solving that. So let's see what Rex does. And while I'm setting it up, whisper to your partner what you think he's going to do to solve it.
Now, new problem. You know those cupcakes you had on Monday? Yeah. Well,
He's my favorite.
cupcakes into Mrs. P put in each box?
I can't get that one. How many cupcakes are there?
There were 20 cupcakes. And Mrs. P put, she had 4 boxes. And she has to know how many cupcakes to put in each box if she wants the same number.
I'll make these like boxes or something.
Okay, those are your boxes, okay. She has 4 boxes. Okay. And she had 20 cupcakes.
Yes. She wanted 2. She wanted 4.
Yeah.
That's 12.
Okay. So, see if our little thing will go away. There we go. Okay, so first of all, why did he have to stop and count? He just, right now, he did 3, 6, 9, 12. Why did he have to stop and count? Because he didn't pull out the 20 first, did he? How many of you said he would pull out 20 and then just distribute them? Okay. But he didn't pull them out, so suddenly here he is divvying them up, and he's going, oh, I don't know how many I've given out. So he stops and he counts. So does he have 12? So, yeah.
Yeah, but as long as he knows he's not supposed to count those top 4, he should get the right answer.
Right. That's what we're hoping, right? Okay. So does he have 12? Yes, because the top row is his boxes. Okay. So a lot of times when we are posing a problem like this, especially in kindergarten or first grade, one of the things we're going to do is we're going to structure it for them, right? So we structure it for them by we saying, okay, I want you to take out 2 different colors of cubes, and then you're going to pick 4 of them and put them out as your boxes of one color. And then I want you to take 20 of a different color, and what you're going to do is you're going to distribute them out one at a time, right? Is that what we do sometimes? Sure, okay. So first of all, kindergarten and first grade students, how good are they at following directions? Right? Not very good. Do they know why they are doing those things?
Because the teacher said so.
Because the teacher told them. And so they're getting really good at following directions, or at least trying to follow directions. But are they doing much with thinking mathematically? No. So this kid did not need to have that kind of structure, right? He chose to put his boxes up. They're not a different color. They're just like all the other ones. And we're going to see if he remembers at the end. But it was his choice. It was his choice. Some kids will, some kids won't. And it's their choice. Do you think that's going to make a difference in their first belief that math makes sense and in their ability to solve the problem, because they're making the decisions? Okay, so we'll see. We'll see if he gets this. Okay. So here we go. Okay, Rex. So now what's he counting? Counting up to 20. He's counting up to 20. Did he get it?
I have a question. How did you know when you said this was 12? How did you know that?
Because I even know how to sometimes come by 3.
You're counting by 3s? Yeah. Okay. So she's going to put 5 in each box?
Okay. Okay, so what did he do to solve the problem? What did all the kids do to solve the problem? They direct them all the situation. Basically, they didn't know if they're making sense of the problem. They didn't know if they were adding, subtracting, multiplying, dividing. It didn't make any difference to them. All they had to know how to do was to count and to act out the problem. Kids can be very, very, very successful if we give them the opportunity to. And this is what we're going to be talking about pretty much for the rest of the week. How do we make them successful? What problem types are going to be easier and harder for kids? What are the strategies that kids naturally have? And how do we progress them from those more simplistic strategies to more sophisticated strategies? Okay? Let's take a 10-minute break. And so come back at 5 after 2. And when you come back, we're going to do math modeling. Do you have any directions for them? Okay.
Nice little break to have. It's hard to sit down all day, isn't it? I went to the cognitive guided instruction training last week, the whole 30 hours, and I was sitting there and I was like, oh, this is so hard to sit here. But it was a fascinating training, and I'm having fun kind of sitting in here because I got to go through the emotional changes like you're seeing. You're like, oh, that's true. And then I have little girls too, and they're 8 and 4, and one's 8 months. And I'm kind of like, that's what I want for them, right? I see these kindergartens, and they can do all this great job. And I was like, I wonder if my 4-year-old can do that. And I'm going home and again and trying it with her. So it was fascinating. So my name's Aileen Rizzo. I work with the county office as a math consultant. I've been there with them. This is my 7th year. And before that, I was a teacher in Arizona for 13 years. High school and middle school was where I taught. So I'm going to kind of go through a little bit of the goals that we're going to go through this week, especially what we're addressing in mathematics. And then I'm going to have the privilege to kind of do a little bit of the practices with you, just kind of review and refresh. I know probably a lot of you are familiar with the practices. So these are our goals and objectives. This whole grant is interchangeable kind of working together with the student thinking and also with the lesson study piece. So as we're looking at all of those aspects, we're looking at these goals as we study the model with mathematics. So we're going to go through all of the 8 standards, but especially throughout the rest of the week, we're going to be emphasizing that 4th one that says model with mathematics. What does that really mean? What does it look like in your classroom? And Raji will be going through the mathematical modeling and the model with mathematics after we go through the practices. But those are our goals to see what is the difference and what does that really mean? Can I really do that with 2nd and 3rd graders? And how is that different from maybe a high school or a junior high class? So when we think of the practices, we have those 8 practices that we've kind of been introduced to. How many of you are kind of familiar with those practices? Can you list them? No, not yet. Not that familiar, but we're familiar. We know they exist, right? So I'm going to pass out this paper, and it has a paragraph for each of the practices. But we're not really going to take time to read through them and all of that. What I want you to do is we're going to break you through and into groups. I'm going to have a group just look at one of those paragraphs and quickly pick out 4 important things that you think are under that practice, characteristics of that practice, okay? We're going to make some posters really quickly because we want to watch a video and kind of see where is the evidence of that practice through the video. So this is really quick. I think I'm going to do one group for each table, except these 2 tables, we're going to break you into 2 groups. So you're going to be in a pretty big group, so kind of have some time just to read, maybe a couple minutes, and then say, I think 4 things are important, and we'll put them on a poster, okay? So I'm going to go ahead and have these passed out. And let's go ahead and do what I said. So you're going to be doing practice 1, only look at that paragraph. Practice 2 and practice 3, okay? 4, and then 5, 6, so kind of decide how you're going to do that. And then 7, 8, okay? So kind of divide there in half. So your poster's right there for you. Right there. Okay. two. Do you need any more? There's two right there. Yeah. Or we have markers up here too. So.
We do have markers for your posters.
Yes. So half a group 7, half a group 8.
But I think about technology.
So yeah, make sure you put the heading at the top of your poster. And your 4 points. Blue tape.
Copies or you
That
have
was the last one. All right. We're ready. All right, thank you. I think we're ready. Everyone has their bullet points. I know some of us are very familiar and some people are not as familiar. We wanted to give a little bit of a time just to review and to look at least one of the practices and see what those are. This is just really the beginning, just scratching the surface and saying, okay, what does this practice mean? But in our classrooms, it's not going to be about what I know or what I can do. It's going to be the opportunities you give your students to do these practices. And when someone walks in your room, can they see evidence of that practice in play, right? Because every grade level is going to have those practices happening, hopefully, in their classroom. So what we're going to do is we're going to look at a video clip of a lesson in session, okay? It's a second grade classroom. And what I want you to do is be attentive to what's happening in that classroom and write down any evidence you see of the practice that you were assigned. Is it being evidenced in that classroom at this point? Do you see any evidence of it being in play? So if you saw something that attributes to your practice, for example, if it's number 1, you need to write down, this is the evidence that I see that practice is happening, okay? And remember, it's the students who are exhibiting the practice, not the teacher, okay? The teacher's giving the opportunity, but the practices say a mathematically proficient student will be able to, okay? So does everyone understand what they're going to do while we play this? Okay. Let's get this set up. Can I escape? Move on yourself? Yeah.
Just answer the question.
look at number 1. They said that there were 82 people. How did they answer this question? Victoria?
Numbers, these words, and use the picture to figure out this. They told us how they did it, and they used base 10 blocks.
Okay, so we know what they did because you're looking at the base 10 blocks. I counted the tens place, then the ones place. I got 82. So did this mathematician break these two numbers up? Where is the 63? Where is the 63? They said they added the tens place and the ones place, but what happened to, I see this number 63 and I see this number 19. Where is it? Where is it located? Sarah?
This number problem down here isn't correct because the 92 minus 85, it can't go up over 92 and 140 is way over.
Okay, so you're making an observation about this problem. Can you hold that until we finish processing the first one?
Yeah.
Okay, I definitely want to hear what you're saying. My question is, where's the 63? Shawani?
Right there.
Where's right there? Give me a... So here's the 63. So this is where this mathematician put 63. And can we say that this is the 19? So we know very clearly that they counted the tens, all the tens. Are there 8 tens up here? 1, 2, 3, 4, 5, 6, 7. Where did the other 10 come from? Where did the other 10 come from? Because they told me their answer is 82, but I only counted 17. Can you tell what they did, Isaiah?
The other 10 came from the 19.
Okay, this is a 10 and that's a 9. But I counted that one. I only counted 17. So where did that other one come from? Come on.
It came from the 1 from the 19. Because they add 10 plus 9 equals 19. And 63 plus 19 equals 82.
16 plus 19 equals 82.
63.
63, okay. Aaron?
What they did is they took the 1 from the 3 and they added it to the 9 and the 19.
They took the 1 from the 3 of the 63 and added to the 9. So, Kaylon mentioned something about adding. He said he wished that this mathematician would have put an addition symbol. Can we figure out that they know that they were supposed to add?
And there's another way.
Hold on, Kaylon. I need someone to answer my question. We don't need to share the air.
Share the air.
What are you supposed to add? Any clue here that tells us that we're actually supposed to add? Ayana?
Because it says how many people are going on the field trip.
It said how many people are going. Are parents people?
Yes.
Are second graders people?
Yes.
Okay. So let's take a look at what this mathematician did for the second part. Because Sarah jumped ahead and said, oh, Ms. Lewis, look at this. The number sentence down here is not right. So let's see what it says. The apple farm is 92 miles from the school. They have traveled 58 miles so far. Let's take a look at what this person did. They said 90 plus 2 plus 50 plus 8 equals 140. Okay. I added the 90, then that, or maybe they meant then the 2, the 50, then the 8. I got 140. So so you're noticing that they did break the 92 down into the 10s and the 1s, but you're thinking that this should be a subtraction? Does anybody else think that? Or what are you thinking? I'm not sure. What do you think? Ayana?
I'm thinking, how did she figure out we're supposed to check?
Very good question. How did this mathematician thought we were supposed to add? So this mathematician took 92 and they took 58. They broke it down and they added it all together. But Sarah's saying, I think they were supposed to subtract. Let's see if we can figure it out as we look at another sample, okay? Yes, Aaron. say, how many more? How many more is the? No, it's a code. It's a code for what? How many more is a code for what? It's a code for. I've heard from you. I've heard from you. I've heard from you. Dewan.
It's code for the number.
It's a code for the number sentence. It's supposed to tell you something about the number sentence. Let's take a look at the next poster.
Advantage, yeah. All right, take some time in your tables and talk about what evidence you saw of your practice, if you saw any evidence of your practice being in play.
It was not showing the whole
Yeah, it
screen.
was sharing the screen. I don't know why. Is that the whole thing?
Showing all?
So how'd you get that?
Yeah, it was cutting off. Well, it's still cutting off a little bit. It's still cutting off.
It's the other
No.
side now. I don't know that we missed anything particular though.
No.
There are many good and bads of the video.
Oh yeah. Oh, absolutely. Yeah.
Yeah, it might be if it comes up, what are the negatives of the video?
We can come talk about that.
We can, they can
Definitely.
have a
Sure.
discussion.
Sure. Every lesson has threads.
So do I go in order and let everyone share, or just let people share who want? How much time do you want?
Yeah, about 5 minutes, but he can,
I would.
we can ask people to volunteer what they,
Yeah, you can ask
everybody
them to volunteer.
doesn't have to force to show, I mean, if they see something, they can talk about it, right? So, yeah, don't feel rushed, I mean, see what we put like 5 minutes to do that one, but if you want to take more, that's fine.
And then what's the next part?
And I think back to you for modeling.
We are talking about
Oh,
what is
the
mathematical
modeling.
modeling and not. So you have plenty of time. I mean,
Now we are ready and we started late.
Yeah.
yeah,
So what you need for the lesson study part?
so 3 to 4 is the lesson study part. So you have until 15 minutes to 3. You have about at least 10, 12 minutes to talk about it.
Okay. All right, so can we come back together? So what we're going to do is just going to go 1 through 8 and say if you saw any evidence and share with us what you thought that evidence was for your practice. So let's go ahead and start with number 1 and we'll work our way up.
Well, as you can see, we had, these are ours, making a plan. I heard just a little bit about using base 10 blocks, etc. Checking answers. She really got into, there's only the 7 tens, and so she really brought up that discussion real heavy. And then making the connection on, well, how do you know whether you add, you subtract, whatever it might be. And she mentioned, well, parents are people too, and photographers or whatnot, and that child seemed to make a connection there.
exactly. So practice 1 is all about problem solving and the different strategies that we use. And even though they were looking at someone else's work, they were thinking in their own mind and making sense of the problem to do that. Great. All right, number 2, practice 2.
Modeling the problem, they manipulated the numbers to create a problem so they could, they weren't worried about the operation. They didn't put in addition signs or anything in there. They were doing, and then when she asked them, does this represent what the code was asking?
Great, definitely. They were talking about even the units, right? Because she talked about, are these people, are the teachers people, are the parents people, right? So they had to talk about units, so you're doing quantitatively. And abstractly, they kind of talked a little bit about a number sentence, what that might look like. Great. Number 3, we saw a lot of this. Number 3.
We kind of thought that the whole little video was all about number 3. It was all about us because they were critiquing. The whole thing was critiquing the argument that they had to follow the argument that someone else had put down. So they had to make sense of that argument, and then they were responding with their own opinion. Well, that can't be right because, and then because that would be totally too many if you did it that way. And she had to structure that because they took things out of order, but it was all about responding to someone else's solution and then explaining either why that made sense or why it didn't.
Yeah, definitely. They were doing some error analysis, right? This lesson's all up there on insidemathematics.org, and it's in parts. And so we saw part 2. And in part 1, she introduces the work of the students, and she said, is it important who did this work or whatever? She kind of makes the structure of about being polite and knowing how to critique someone else's work. But that's what it was all about. They were all justifying their own reasoning and critiquing, definitely. That was all about 3. Number 4, did we see any model with mathematics?
I think we felt like they were dealing with kind of like everything. I mean, their everyday life. I'll start from the bottom, go up from on our PS, the everyday life. It was a field trip. We assumed, right? Okay.
It was.
So it was a field trip. That was everyday life for them. They were applying the numbers and miles and whatnot. They were using prior knowledge just because the one kid pointed out the code word. So I assumed that somewhere along the way he had been taught how many more, and just like their knowledge of base 10, their knowledge of so wherever they got that was, whether that teacher or before that, they were doing a lot of that. They were really a lot of checking to see and listening to see if what when they were sharing the error of what they were saying and listening to each other, and identifying, analyzing, interpreting, and reflecting. They were really looking at that, really pulling that problem apart and parsing it and looking to see what was working and what wasn't. And they seemed really comfortable. I mean, they were like right there, very comfortable in their talk and not afraid to share out.
To share out, yeah, definitely. Thank you. Number 5, let's move on. Number 5, where did we see that?
Well, paper and pencil is still but the one thing we saw that was really big was the detect errors using estimation that talked about that knowledge of practice. Because I think the one girl said, well, you can see that 89 plus whatever the number was over 100, so the answer must be incorrect. So she was using those
Definitely. So we didn't see any use of actually a tool. Maybe we would think of manipulatives or a ruler or anything like that. But we did see the way that she was talking, the mathematician represented this way. They didn't use any addition signs or anything like that, but they were using that 10 as a group and having ones as a group over there towards the side. So they were using a tool for them that was their tool of maybe drawing out that or writing that in some way. So that was evident a little bit, and definitely we saw that with the detecting errors. Kind of, she was making an assumption and estimation. That's great. Number 6, attention precision. Did we see that?
Well, 2 things that we noticed. One, they were when they were speaking. I added the 10 place into 1 place, and I got this. So they were communicating how the mathematician We already talked about how they didn't really use symbols, but one little boy said, I wish they would have put a plus. So they obviously had that knowledge, even though they weren't using it, they knew in some instance which they would.
Was there anything else? That there was a mistake, right? Yeah. So definitely, you brought up both of the strong points of attentive precision. So attentive precision is the calculation part, but it's also in the vocabulary I used. So you brought that out. The students were using that vocabulary-based tens, the tens place. They were doing that. They weren't saying that number there, right? They were being precise. They were trying to be precise. So that's definitely was coming out. And then they had to come up and point. Helping them be more precise in their language, definitely. Yeah. Number 7, look for and make use of structure. Yeah, definitely. So this was a Mars test that they all had done before. So they were definitely using the structure. Probably didn't get to see it as much as you would have if you've seen all of the parts. But then she was about to flip the page, and then she was going to show them another way a mathematician solved it. So they were making use of structure. Seeing someone solve it in different ways lets you make use of that structure over time. You kind of see the patterns. You can kind of not only critique the reasoning of others, but see where those errors are and how they relate to each other. So definitely happening there. The last one, number 8. Did we see that? That one's a hard one. Yeah, definitely. And that's another one that probably could have come out more the more parts of the lesson we saw, or if we could see it in its entirety, we could have seen even that come out more with the patterning and evaluating your response and looking through that. So although you may see all the practices in a lesson or part of a lesson, your goal really is as a teacher isn't really to say, I need to teach all of these 8 practices every day, right? Although they may come out. Maybe the goal of this teacher was practice 3. And it's so evident because that's where she wanted to give a lot of attention to. Her focus was, I really want to give them a chance to critique the reasoning of others and to construct a viable argument, right? So that's what, as you're thinking of your lessons and as we go through this lesson study, think about a core of practices, 2 practices, maybe 3, that you really want to emphasize, that you really want to make sure that students have an opportunity to put that in play and have evidence of that. So we're going to go through some of that, and as we go through, we're going to hopefully give you a chance to continue to talk about it and continue to see these practices in play. I think you don't learn something until you actually have to teach it, right? And you have to use it. And so the practices will become more familiar as we do that. So we're going to transition to some modeling and hand it over to Raji.
Hi, my name is Raji. Raji is the best way to call me. I'm at the mathematics department at Fresno State. So we talked about all these 8 practices. What I wanted to really think about is the model with mathematics and how it is, what is the value of it. how we can use this modeling mathematics, bring them into our class. Often it says, if you see the students practice model with mathematics, you will see students doing all the other things in your classroom. Before we go there, it might be a good idea for us to think about, do you know where this beginning of the Common Core standard, where did it come, how did it originate? Yeah?
We can see that our students were not progressing as well as students in like HSP X and Explorer, and it was really that our children are competing with other nations and their abilities to think at a deeper level and create and have kind of a understanding.
Exactly. Who said that? Who were the people saying that? Not the government. People in the industry came back and said to the government, the governor saying, you are not producing the students that we can employ in our class. So that's why the governors or the states could not refuse, because these are the people who are hiring the people. And they said, compared to, we have to import people from the other countries to our companies because we are not producing. So that's the beginning of the Common Core. And the core of that need is the model with mathematics. People want the employers who can solve the problems that needed for India. And that is where the beginning of the mathematical modeling. So mathematical modeling is slightly different from model with mathematics, but I want you to see the difference between these two things and then put it into perspective what it really means. What can I do in my classrooms to see that the students modeling it? So next few days we will be taking you through that experience, and then hopefully you can see the value of that situation. Why cannot I do it in my classroom? And that's the experience we want to have. Before doing that, let's think about what think about what is mathematical modeling. You might have heard about it, you might have some vague idea. Let me take a minute and write it down oh, before I say this one. So all of you have this, all of you have this nice binder, and you have all these tools. These tabs here, you can organize. We originally planning this workshop, we are thinking about, we should give them the title for these tabs. And then we thought, no, we should let them organize the way that we want to do that. So you are free to organize it any way you wanted to, day 1, day 2, day 3, day 4, or the mathematical modeling, student thinking, any way you feel comfortable. But I want you to use this information throughout the year when you are doing the lesson studies and when you are meeting in your groups and so on. So make sure to use this one and keep some of these ideas. Just like our students, you wanted them to keep that information whenever you want to pull them out, it is there. So take a piece of paper and can you write down on your own, without talking to everybody, what is mathematical modeling? What do you think about it? can you take few minutes to share your ideas with your group? Think about, talk to the group and see whether you can agree on what you have written.
Students solve problems with tools and articulate the steps they follow to get to their end result using vocabulary appropriate for the task.
Do you guys agree?
Yeah.
Something similar for everyone?
Oh no, yeah, that for sure. That's given big thing.
Okay, so let me I heard some very valuable, very interesting definitions, very good ones. Let me share some of the very common definitions of mathematical modeling. What I want to talk about is what is defined as a mathematical modeling and what is not also. There are many times I have heard very different things that we use in our vocabulary for mathematical modeling and which are not. So what's going on? I guess so. So this is one of the early definitions of the mathematical modeling. I actually heard few people were talking about it, using mathematical tools and methods to ask and answer real world situations. So oftentimes mathematical modeling has some real world problem, and then you use mathematics to solve that problem, using the tools in mathematics that we know to solve that problem. This is by the NCTM. Mathematical modeling is the process by which students encounter real world situation, pose a question regarding the situation, and use mathematics to seek an answer to the question. Mathematical modeling involves identifying the relevant features, symbolically analyzing the model, and considering the accuracy and limitations of the model. So you have a problem and you use the mathematics to represent that one, then using the mathematics, things that we know about the mathematics to solve that problem. One key feature in this model is the cyclic process of that one. You saw in the video that you were watching, you solve the mathematics, solve that problem, and then the teacher and the kids are going back and see whether it makes sense or not, right? So the mathematical modeling modeling has this cyclic process. So you have a problem, and then you are trying to solve that problem, and you can go as many cycles as possible to try to figure it out whether this my answer makes sense. Am I solving that problem? Once you are satisfied, then you go back and report this is the answer to my problem. So this cyclic process is very important. It is not like you are getting a problem and solving it and saying that this is my answer. Going back and see, does it make sense? Let's think about what is not mathematical modeling. If it is a mathematics classroom, and if the teacher do something and asking the students to do the same thing, it can be interpreted as a mathematical model. You model the mathematics you want your students to do, right? But that is not what mathematical modeling means. Let's go back and see whether it works this time. Now? Good. Even using the mathematical manipulatives, if you use the mathematical manipulatives to represent a problem, is not considered as a mathematical modeling. Even if you use a graph, equation, and function to represent mathematical problem, it is not a mathematical modeling. Mathematical modeling is a cyclic process of trying to solve that problem. Yes, that's correct.
Answering the question, that was a misconception that I had, because I thought it was just some kind of a representation of the problem, and so I'm adding to that with, it's the process,
Correct.
not merely the representation, but the process.
Correct. Representation is a part of that whole process, but not itself. Is that clear to everybody? That's one of the biggest misconceptions here. Yeah. So this process, this first step number 1 is understanding the problem, read the question about the problem, identifying the issues, you wanted to understand, and knowing exactly what you want to know. That is step number 1. And oftentimes these mathematical problems, we have to make assumptions. Everything is not very clear. Often that we use the problems that we solve in the classrooms, we give everything that students need to know, right? But often the real life mathematical modeling, we have to figure it out, what information should we use, what we should not use, and that is a part of that process to identifying those information. Actually these slides we ask Rob and Jeff to share with you, so he's going to put these things into a Google Drive that all the teachers are using, so we'll be able to share some of these ideas these slides with you. So this is the step where you can use representations, you can use equations, you can use your graphs to solve the problem part. And the fourth step is, once you use that system to and try to figure it out, some answer to the problem and see whether that problem makes sense or not. And if the answer does not make sense, then maybe some of those assumptions that you made were not right, and then you go back and change and make the different assumptions and try to solve the problem and make it make sense of it. So, so this is what we talked about is mathematical modeling. There is a slight difference between mathematical modeling and modeling with mathematics. Remember that those two are very close words, right? So the 8 mathematical practices, what you have is a model with mathematics, and the mathematical modeling part that have is much more broader one, as is the one that we have been talking about. So when you think about model with mathematics, they are very close, but there are slight differences in the model with mathematics in the classroom. So if you have someone coming to your classroom and see whether your students are practicing model with mathematics, then they don't have to see that whole process. There is a different interpretation of model with mathematics. So, so the definition that you have written up there. The model with mathematics standard says mathematical proficient students can apply mathematics they know to solve problems arising in everyday life, society, and in the workplaces. However, the standards give these different definitions for different places. For example, elementary school, that model with mathematics can be as simple as writing an addition equation to describe a situation. Right. So we saw that the earlier clips that students are using, you are given a mathematical problem and they are writing equation, or they are using some kind of a manipulatives or something to represent that situation, and that can be considered as a mathematical model with mathematics. It is not the mathematical modeling, but it is represented as a model with mathematics. Does everybody see the difference between those two? So this is one actually very relevant to the grade levels that you are working. Questions? You see the difference between those two? If it is a middle school, students are applying proportional reasoning to plan a school event, analyze a problem in the community. So it is much more broader, much more closer to the actual mathematical modeling situation. And the high school, so actually when it comes to the high school level, there is a content standard is called mathematical modeling also, completely. So they have like algebra and with all the other contents, there is a content standard called mathematical modeling, completely separate from the other ones also. So next few days, what we are hoping to do is, with the model with mathematics, giving you problems similar to what you want to do, what we want you to think about with your own students, and taking you that experience. what is that cyclic process, and see, do I enjoy doing this problem? And if it is, then your kids will do the same thing too. They will enjoy that process. And we wanted you to experience that one and see whether you can do this in the classroom. At the same time, there are problems in your textbooks. How do I convert one of those problems into a mathematical modeling problem where the kids can enjoy, rather than it is a punishment, it is a fun activity to do, right? So that's what we are hoping to do in next few days. We want to switch gears. One more thing that we wanted to introduce is the lesson study. How many of you all have heard about or have experienced lesson study? One out of. Well, tell us a little bit about what you have seen. Different workplace, different place. Yeah. So lesson study. So let me switch the. I want to get out of this, so whatever it is there right now. So let's see.
Yes, I'm wondering if part of the issue has been that somehow you need to connect your computer after you have
load it up.
Loaded it up. I've had trouble with that sometimes with my computer. That it doesn't register as kind of format as easily.
That is a possibility. Let's see. Here is my. Yes.
Okay, so now plug in.
But make it bigger too, right?
No, just take it out. Okay, now plug in the projector and see what it does. And now
you are thinking about the professional development as a teachers. Can you think about what would be your ideal if you think about I wanted to grow as a teacher? What do I need to do? What is my district can do? What is these people can do for me? Can you think for a couple of minutes and write it down, those ideas? Maybe 3 ideas that you can think. I want to grow as a teacher. What can somebody do it for you, or what can you do, or what can the school district do? Can you write it down? That's great. Okay, yeah, that'll be good. Okay. I would like to hear from from different groups. One time I asked that question and we had like hour and a half, and it took the whole hour and a half for that discussion because everybody wanted to say something related to what they wanted to do. But we'll, yeah. So let's use for about probably 5 minutes. I'll hear from different groups. What do you guys think? Mm-hmm. Few things, maybe one idea or something. Mm-hmm.
And one thing that kind of goes along with that is like, I know our whole, I mean, we're all focused on more testing. Testing because it tells us what we're doing, how we're doing, whatever. But when you are focused on testing, there's so much pressure to get that addition lesson taught in a day that you don't always have time to let the kids play and explore. It's wrong, let's do it this way, so that you get it right on the next time. Yeah. And it's just being, not that I think it's right, but realistically, if we're going to make them test every quarter, and they have to know it in that quarter, it's not a lot of explore and figure it out on your own, because that is great. But, and it's not allowing us to be dead any of the applications. You're saying, you know, you're going to have a dialogue on one problem, and you're going to spend a lot of time, you're going to embed a lot of things, and they're going to become rich in knowledge, but it's not going to be the everything that they're going to test on. You give them the test, and then you say, this is the test, because district wants you to take this test. They can be able to do this with authenticity and have permission to have those things extracted from our plate and take this on and really do it the right way instead of trying to do it. Or scores come in and then
You're saying what Jeannie was talking about, like you cannot do that holistic approach to the students. That's what you're talking about.
between the PD and then the actual district policy, if everybody's on the same page.
Since we're special, since we're in here, we're going to make it
I think so. That's what she's there for. I think this is the one part of the grant is the institutional change, and I think with our interest and so on, I have seen places, school districts. I mean, I know that even some of the school districts that Jeannie has worked before, school districts said have two different policies. This group of teachers, you can do whatever you want, and the others, this is your policy, because they saw that the effect of what they are doing in their test results and all those things. So I think it is you will be driving that force, and you can make those changes too, and we will do our best to make that changes too. My mm-hmm.
Well, and if I can just add, you know, the units were by design because we as teachers were looking for ways to help us get into Chem 4 right away through what does this look like. So they were designed in response to that. Now keep in mind, the curriculum department is right here with you guys, where this right. So we see it all, and we're all a part of it. So it's not the curriculum department versus, you know,
let's hear from some of the few of the teachers who have gone through this lesson study process. They were talking about their professional development experience. So this is a video of some of their ideas.
Working together as people, not trying to do it by yourself in your own classroom.
It was something that I was looking for, more collaboration with colleagues.
A lot of times teachers, we have so much going on in the school day, we're always busy. Getting time to just have teachers meet together is something that's not so common practice, I think. I heard about the Chicago Lesson Study Conference, which was organized by Dr. Takahashi, All University. And I went to this conference, and we observed the lesson that had been carefully planned by a team of teachers, and the lesson ended, and we sat down and we had a very in-depth discussion about the lesson. It was very respectful of the complexity of teaching. The fact that you could watch a 45-minute lesson and then have a 1.5-hour discussion about it, and maybe still even at that point not be done. I thought, this is what I want to do. We helped create a professional but critical discussion about the lesson. What worked in the lesson? What didn't work? What is our evidence? What do we see students do? What does that tell us about how they're thinking? And what does that tell us about how we move forward in future lessons? As these cycles continue, teachers start to build on their skills. It's really built my ability to react in the moment in the classroom, to respond to what a student might do or say, to have a sense of where the discussion or where the lesson might lead. Lesson study is the way of bettering your practice. I haven't seen any other professional development that has been as effective and impactful in my teaching life and on the learning of my students as lesson study.
So the lesson study is a tool used by the teachers to have professional development have a professional development.
Was the fake Christ, the counterfeit Christ, the Antichrist.
The YouTube goes to the next video, whatever it is there. So the lesson study process, actually what you will be doing is you will be working in groups of, I think about 4 to 6 teachers or something. I think Jeff has already divided into lesson study groups. So you will be working on developing lessons. But the lesson is not the essence of this one. Lesson is the destination, but the destination doesn't matter. What matters is when you are developing that lesson, the journey that you go through, the talking to each other, observing the students, learning through that lesson, and discussing what happened in the lesson. That is the enjoyable part. That is the fantastic part of that one. At the end, you have a lesson that you might be able to reuse later on in life. If it is sometimes it is a bad one, then you can learn lessons from that one. I never wanted to use this lesson, but it doesn't matter whether the lesson is good or bad. It's a journey that you go through, that try to figure it out something is the matter. So the lesson study, the birth is in Japan. They use, actually what they say is, they use the research developed by the US and implemented in their classroom, and that's how the lesson study came. We had the research, but we never implemented it. That's why we didn't. But we saw them, and a lot of researchers saw how effectively they use in the classrooms, and they brought it back here about 10, 15 years ago. And when I saw that one, I was saying, wow, this is fantastic, and we have used with the teachers, and teachers, every time we had the lesson study, people finish the lesson study, wow, I never thought that my kids could do that. I never thought that this can happen. So that's the feeling that I want you to have, that also. Oftentimes when we have the lesson studies, even the grant is over, sometimes the schools continued it. If the school did not continue, these teachers still work together and perform something similar. So, so I need to introduce you what lesson study means. So, so the all of you all will get a little booklet about the lesson study, and you will get a chance to read and figure it out. And then throughout the year, actually we start with this week, and then throughout the year we will do 2 lesson study cycles, right? So lesson study is has a different, it is again a cyclic process in a way. You have in a group, you get together and design the lesson. First of all, you will come up with a research goal other than mathematical content you wanted to see. Then tomorrow we will work on this one. You'll try to figure it out. What are the weaknesses of my students? And try to figure it out. What is my ideal student? What is the difference between those two? And then you come up with idea. Let's say if you say that my students are not motivated to learn math, or whatever the topic that you have, then you design a lesson teaching math content but fulfilling that goal. So your research goal is motivating your students, and you design your lesson to see whether you can collect evidence that, oh, I can see if I design the lesson this way, my students are enthusiastic, my students are motivated to do that one. And then we'll figure it out, okay, what pieces of my lesson allowed me to do that one. And then you can try to, what happens is when you see that one, you try to do it in other lessons and any lesson that you teach, because you wanted to achieve that result, right? So you have a, with a group, you have a research team, and then you design a lesson, and one of you in the team will teach the lesson, because since all of you design the lesson together, it is not a one person's lesson, it is a team's lesson. So when you are observing, if the lesson did not go, it is not the person who taught the lesson, it is the person who designed the lesson. And then you come back and look at what part of the lesson that did not go right, or what part of the lesson that worked well, and then try to figure out how to improve it. And then someone else teach in the classroom, and you go through the same process of observing. So for all those things, there are little protocols, how to observe, how to collect data, how to debrief the lesson, and all those things. There are ways to go through so that nobody will feel bad about that lesson, and then everybody will have a best benefit out of it. And all those lessons, you will have people coming outside and observing and so on. So that is the lesson study process that we will be going through. So again, as I said, it is a kind of a cyclic process. You are goal setting, and then you have a research lesson, and you discuss the lesson, and you change the lesson, going back to the goal setting and so on. It's kind of a cyclic process that you will be going through. Second year, you can change your goals and come up with a new goal and go through this process. So this is the same thing I mentioned earlier. You are working together, determine the needs of the students, design a research team. You use the best available resources. You look at what are the areas that your students are weak at. If there are certain content areas students weak at, then you can focus on math content on that part. And then you teach the lesson and recollect the data and redesign. So that's the process. This is some of the pictures of lesson studies. So these are 5 teachers designing the lessons together, and one person is a kind of a note taker, another person is a facilitator, and you are discussing. You have to first you have to design like a norms of your groups, and all those steps are going through. And then one person is teaching the lesson, and oftentimes the other people collect the data. So the other teachers are standing around this group of students. How do they receive the information through the lesson? Then you have a chance to listen to each individual students and get an idea about what you hear from them. Often when you are in front of the classroom, you don't hear every student. Often these lessons put so much energy and so on. Most of these are very enthusiastic classrooms, not just a lecture type lessons. And then after the lesson, people get together and debrief and talk about what happened in the lesson. Often in these ones, the person who taught the lesson will talk first, and then you will take turns and talk about the data that you collected and figure it out. Did it happen? Did this research goal that we had really achieve? Did we really achieve it or not? And this is another one, debriefing, and then you reteach the lesson. So usually there are different formats, different how much time you used and so on. This varies. So in our process, in this week we will try to go through the first few steps of the lesson study process during this week, and then we will have two more, well actually 3 times we will be having whole days to teach the lesson, reteach the lesson, and designing the lessons we will have during the year, during the first semester, and then we will go through another cycle in the second semester. So we will have 2 lesson study cycles during the year. So what I wanted to do is I want you to give you that lesson study booklets that we have. So I want you to actually, I was originally thinking to send these books at the beginning of the summer so that you will have time to read on those things. But somehow it did not happen. But that's okay. We'll have some times to look at at least chapter 1. So when you take the book, I want you to, in your groups, to dissect chapter 1. So open the books and look at it, and I'll give you your assignment in a few minutes. Get a book also. So look at page number 7. So what I'm going to do is we will try to dissect this chapter and try to figure it out what is in this chapter, right? So I will assign bullet number 1 for this group, right? Number 2 for this group, number 3, number 4, number 5, and your number 6 is the one that I want you to I want you to tell us about this part.
Okay.
Right? Are you clear about what you are supposed to do? Right? Okay. So give us a summary of what is talked about in bullet number 2, right? If you wanted to use a piece of paper to write it down, or if you want to use a poster board, you can do whatever it is, but I would ask you to give a summary of what that chapter is talking about, right? Are you guys sure know what you're doing?
Just reading it right now, right?
Reading it, and then I would ask you to give a summary of what is talked about in that particular bullet point.
Okay.
Right? Do you know what you're doing?
We're doing
Number 4, and I will ask you to give us a little summary of what it is. You can, if you want to write in a piece of paper with bullet points, or if you want to write a poster paper, whatever it is, we can tell everybody what it is. You guys are number 5, right? Give us a little summary of what it is in the bullet number 5. Your part is very little, but it is very valuable part.
Yes, absolutely.
guys good? Good.
We're supposed to come up with a summary collaboratively, or you'll
That's
just
true.
call on somebody?
I can call and then you can talk about the pieces, or if you want to, if one person wanted to write down everything, that's fine too.
Okay. I had one question,
Mhm.
and probably actually two. When you were talking about this area, model with mathematics,
Mhm.
so you used two phrases, model with mathematics, and then you used
Mathematical modeling.
mathematical model.
Modeling.
Okay, so I feel like I kind of missed something. Okay.
So the mathematical modeling is more widespread, existed for a long, long period of time. But the model with mathematics came with Common Core state standards.
So that's more the lessons with the hands-on and all of that, and then
Correct. So it's a different idea is to take the students to this level, but like elementary school level, it is hard to take the students to do full-blown mathematical modeling. So that's why even the representing the equation is a model with mathematics. It is not the full-blown mathematical modeling, but it is model with mathematics. So it's like if you think about modeling, mathematical modeling is a huge big thing. Model with mathematics is a part inside that.
so this is the model with mathematics is more the CGI method.
Not necessarily. Not necessarily. CGI is more about student thinking rather than model with mathematics. So model with mathematics is so if you think about mathematical modeling is a whole big process to go around and that cyclic process. Model with mathematics can be a small part of that process.
So this is that this.
Yeah. So this is if you think about like if you look at this one, this can be
The model.
a part of the mathematical modeling, not the whole mathematical modeling. So this is a part of this one.
Okay. So each one of these, the 8 of these are each a part of that. And
Well,
when you
if
choose
we use this one in the classroom well, if you use this one in the classroom well, you will be doing this one and all the other eight together.
So this would be the 8 together, and this would be focusing on one as a lesson.
Kind of, you can say, not a lesson. It's a way that how you look at the mathematics rather than you are solving problems. It's a much more creative way to solve problems and how you look at the problem and so on. Yeah.
I think I'll get it over time.
Yeah, I mean, we will be going through this one and then you will see more and more. It's hard to, even these 8 mathematical practices, I learn, I mean, I have been talking about this one last 5 years, but every day I learn something new about that one too. Are you guys good? Talk about it? Okay. Are you guys good? Okay. Are you guys ready to talk about it?
Yes.
Good? Okay. All right. So, are you ready to talk about it? Yes. So, the question is why lesson study? The question is why lesson study in these five bullet or the titles kind of try to address that. Why is that? What is the need for that one? Why do you have to use lesson study? So let's hear from each other. What did you read and what are the key ideas from this one? So let's start with one. And what did you find out?
Some of the things that kind of stood out to our group were that in these lesson studies, first of all, the most important thing is going to be to leave your ego at the door and be willing to be open and honest about talking to each other, because there's so much we can learn from each other if only we'll be quiet and listen. And that it is a focus on student thinking. We're always concerned about this is the end result, I need them to add A and B, rather than this is how they're thinking about it, therefore how do we plan our lesson so we enable their thinking to make them be successful. One of the comments in here was that lesson study has been classified as differentiated learning for teachers. We we always worry about having lessons different for our students, but we don't often remember we're also students and learning all the time. And then you pick one thing and you focus intently on that one thing, and you don't just focus on what's the best workbook page for us to use, what lesson are you going to teach in math today. It's more, how are you going to do it, how are you going to get there, what strategies are you going to have the kids use. And they also said, and I thought this was really bizarre, that a lack of collegial work environment leads to more teachers leaving the profession more than any other factor, even salary. We lose so many. I came into the profession late. I had a different profession, came in late. So I'm always doing things backwards. But you guys have had so many wonderful people, and then, like, my kids are graduated and in college now, and I go back and I say, is so-and-so's good? Oh, no, they weren't. And they were wonderful teachers. But, but I really think that part of it is going to be being willing to listen, and again, leaving that ego at the door, and hearing what people are saying, and being respectful of one another.
The many studies done with the teachers who left the profession and stayed in the profession, number one reason for them to stay or leave is the community that they are working with, the collegiality of the groups. Lesson studies exactly that. You are working with your groups and learning from each other and so on. And on top of that, another one important piece I don't want you to miss is the teacher is not someone tell to do something in the classroom. Teacher is a professional. You decide what you do in the classroom and how you do in the classroom. So with the group together, you become a professional to do that what you learn to do best in that classroom. So that is the part that talks about this one, that I want you to make sure that is the piece that give the enjoyment for the teachers in their profession. I think that's another one of the key ideas also, right? Okay, let's hear from the bullet number 2.
Okay, ours was about important learning structures, and it's kind of interesting, the little diagram it gave us. It talked about how it compared us to Japan and how it's completely backwards. If we spend more time looking and finding curriculum and planning for lessons, and we spend the least amount of time watching and discussing each other and talking about and growing from that.
Is that true?
Yeah. Yeah, and then it talked about, yeah, it kind of like, I guess I said that they wanted to redefine 2 words, and one of them was problem solving, because they asked teachers what problem solving meant, and they said basically solving word problems, and that's not really what problem solving is. And then also it talked a little bit about data that I thought was interesting. It said that it consists of the results that we get our data from testing, basically, and that kind of tells us what we need to improve on, but it doesn't tell us how. And if we change the way we look at data, and if we're looking at through and comparing each other and students, then something improves the how instead of the what.
Do you agree on those ideas? Let's move on to number 3.
Was lesson study values a long-term learning and development experience. Some of the focus was I underlined each of the keys and build upon each other's ideas during discussions, take careful notes, work effectively, carefully, and take initiative learner. Those are the qualities that we want to build in our classrooms, that those
Did everybody understand the what she's talking about? Because we will be working on that one tomorrow. I think, yeah, end of the day tomorrow. So the lesson studies, when we focus our research theme, it is not going to be about the math content. It is about some other content that you want to develop on your students. So you have to think about your own students. The holistic learning that she was talking about, not only the math content, it's a holistic as a person too. So you have to think about, for my students, this is what I wanted to see. And that is the idea that you're talking about. It's a long-term goal of the school, and sometimes it's the classroom, that long, what you wanted to see in my students in the long run. Does that make sense to everyone? Yes. It's
the first time, but once you get used to it, it's really enjoyable to work with each other and develop the lesson, and then be able to see how each person presents it differently, which actually motivates you to maybe change something that you have not changed in previous years. So I find that it is very motivating.
you have to go through the experience to see that, right? So I should. I should not ask you whether you agree or not, because you have to, once year from now I should ask you, do you agree with that one or not? I will do that. How about number 5?
Lesson study builds knowledge base for teaching. It goes back to number 2, working with your coworkers. To improve teaching and learning through development of shared professional knowledge, knowledge base of teaching. When you're building your units of your lessons, that you're considering not only the lesson, but how your students think. And to be prepared for something that, if they're not sure, if you're talking about a 200-pound sack of coal, you need to have a sack and show them how big it would be. So we have to give them those extra visuals. So it's developing relationships with your partners, so you can improve construction. I think that's it.
So the lesson studies that you will be going through this coming year, one of us will be with you in the lesson studies, helping you in any places that bringing the resources. So let's say you are developing a unit on fractions or whatever fractions, then we'll try to figure it out. Okay, what are the resources that we can bring it to you? Or there are places that we stop the lesson and try to figure it out. Okay, what does it really mean? And sometimes there are the people in the group, I have taught it this lesson in this way, and this is what it means, and then you learn from each other. In my best learning, I mean, I think I have learned the most, not in my PhD program, but when I went through the lesson studies, sat with the teachers and observing their classrooms, I did my best learning through that process. So I think I grew more in that process than anything else. So you learn your content and pedagogy, everything through that process. That's the important part of it. Okay, this group has something different. I gave you a different task, not different task, different question. So your question is, you can talk about it. And
We did the frequently asked question, why would you want to spend so much time planning just one lesson? We kind of just talked about how it's the habits you create and learn by collaborating and working together, and you're learning how to give a good delivery of a lesson, not necessarily the content. So it's like you watch those shows, Food Fighters or whatever, they have excellent cooks, and they ask them to cook something, and they have never cooked that exact meal before, but because they have all of the tools and resources to cook effectively and well, they can take what they know and cook an excellent meal. It's just taking everything and learning how to be a good teacher overall for any lesson, not just that lesson.
does it make sense? Oftentimes, this is the part that was very hard for school districts to adapt. Principals ask us, why do we spend two days giving subs and all these things, teachers preparing just one lesson? What's the deal? I mean, at the end of the year, you only teaching 2 lessons, developing 2 lessons. it is not worth, we'll have to spend so much money to this, giving subs for these teachers to do that one. That is a part that was very hard for the administration to understand. But I think, but that is the most valuable part, exactly what you are saying. It is not that lesson that matters, but it is the all the tools that you are learning to get there. It's a journey that goes through there. So all this based on the student thinking. The first group mentioned about the student thinking. That's why I think the student thinking part that we do in the morning and the lesson studies as a really nice merger together, and then you can grow as a teachers in those two process. Okay, so next few days we will be going through this actual lesson study process starting from tomorrow, right? Jeannie, you wanted to give them something, and